Hey, hi everyone. Welcome to this new video. So in this case, we will do a use case. Okay, and this use case is creating an AI agent for doing NGS quality control. So like in NGS, like Illumina or any sequence data, what you use, FastQC is a popular tool which people use to generate the quality, not generate, they're checking the quality. Okay, so that it gives us the report, and from the report we can evaluate. But if you remember, like, so we manually evaluate, right? So we run the first QC, we get the QC report, and then we check each of these output of the first QC, and then we decide, right? So just to give an example, this is the first QC tool. Um, so yeah, if you go over here, it gives this such nice HTML report. So let me show you one example of good Illumina data here. So on the left hand side you will see a different statistics, like basic statistics, like what is the file name, encoding, total sequences, total bases, like all these parameters will show. Then it will give us per base sequence quality, and it gives such this format. But at the back end also, all this, for this all we get a matrix file. So, and you usually either look visually through the plot, or by some metrics you can decide whether it's a good quality or bad quality. For example, let's say if you go to bed Illumina data here, you will see that the quality is, mean quality is very poor towards the end, right? So this gives us some information like, okay, this is mainly a bad quality, I need to trim it probably, right? So that's where we can have an agentic workflow here. So this is just an example, hypothetical example. Let's say we will have a agent. We just need to provide the agent the FastQ file. So the agent will run the FastQC tool in my system, in your system locally, and then it will get the output, and then it will parse this text file behind the scene, because these agents are good at see, you can use image model to do that, but that is very costly. So but you can get some text, because these model are text, right? So you can pass the behind the text output to, so that and we can provide some tools to the agent which will help us to understand what this mean by, and based on that the agent will be able to provide some a decision, like whether it's a good or bad quality, those kind of thing will do. So okay, so what, so this is what the flow is like. So basically the user will interact with the FastQC agent, and where the user will provide, this is my FastQC file, FastQ file, and it will, the agent will run the FastQC. So we will equip that agent with a tool called run FastQC. This will run the FastQC tool by in locally, and then the FastQC, when we run, right, we get the output in a zip file. So that's what we need to equip the another tool, where it will extract the FastQC file, unzip it, and then it will parse the output from the main QC file. Okay, and for that, for now, in this use case so far, only I have introduced three functions, basically to parse this basic statistics, and the second one is per base sequence quality. Okay, and then overall this a green, this is good, bad, warning, this parameter summarization, that is the third parameter, like parse all the module verdict. Okay, so similarly you can introduce many tools, but so far in this use case what I will show, we'll just go with these three utilities. So now we equip our agent with all these functions, and with this we just don't have to orchestrate anything, so the agent will think, okay, user has provided me first QC, so first let's do this one, then unzip it, then parse, and it will do automatically. That's what we will see, the agentic workflow. Because if you run this in a non-agentic fashion, you will write a simple bash script, first you will run this one, then this one, then this one, like that, right? Sorry for that. But now in agentic fashion, we are telling the agent to do everything. We are just telling that you have this capability, you decide how you want to run it, and ultimately give me the output. So that's what we will see, how the agent will think, and it will do that. Okay, yeah, so before that, let me show you how the output looks like. So in the folder I have this FastQ file, which I will give as an input. This is a very bad FastQ file. Okay, and what will happen, it will run the FastQC, and basically you will get an HTML report like this. Okay, this is the actual output what we get. Okay, so you see this is very third class, very bad, poor quality, um, what the file, and the basic statistics looks like this one, and it's fail, and the per base sequence quality will look like this, all that. Okay, this is a HTML report, but we will not parse this HTML. So it will, as I said, it will provide a zip file as well, and if you extract the zip file, you will get a folder like this, and within that you will have something called FastQC data.txt file that contains all this, whatever we see in the HTML, right? Everything is in the text format. So now you see the basic statistics over here. Okay, so that's what I have written, a Python function to take this file and parse this much content, and it will generate the this will goes to the LLM or agent. Now the verdict, right, this green, what you see, green means tick mark or cross or warning, that is there in this line, double arrow mark. This is the per base sequence quality, this is fail. Next, after, if you go down, per sequence also fail. So I have written a Python function which will parse, double, this greater than this one, pass fail, and all this module, and this will also, we are sending an output. This is the third function, what we have written, like, parse all the modules ka verdict. And for this one, right, so what I have done is, like, I have written a function here, Python function, which will basically for every base, what is the mean quality, right? For example, first base, the mean was 5.45, which is out of the scale of 0 to 40, it is 5 mean, and similarly 4, 5, like that, and then comes the range from base number 10 to 14, and the average is this one. So basically I have written a Python function which will take this content, from this content, and then it will take this mean value and it will calculate the mean of mean, so that means this is the mean quality, the blue line you see, right? For this we will get a mean, and the mean will be around somewhere here, that means 10 or something, and based on that the agent will decide that, okay, the overall mean base quality at all the position is around, let's say, this much, and it is very poor quality, and so it will say its final verdict, like it's good or bad. So this way we can also train or equip our agent, multiple tools to do that. Okay, so cool. So let's now go with the practicals here. I showed you like how we'll parse it, right? So first, just load all the modules, required modules. I need this sub process module because that's where I will be running FastQC. I have installed in my FastQC in my system locally, and it is in the path. So agent will be able to run it, this one, FastQC, and I need to extract the zip file. So that's what where I will be importing using this module, zip file module, and rest all are that agent related libraries. So let's load all the libraries what I need, and then what we need is loading the environment variable so that my OpenAI keys is loaded. So now I will define all the tools as a functions, and then decorate it with function tool. Okay, so first function is the FastQC function. So this is the run FastQC function. This will take the input directory and it will run in the output directory. So this is, I have given the instruction that see, run FastQC on the given input file. The parameters are input file, output directory is optional. Directory to save the FastQC report. If not passed, then uses the current directory. And basically if that output directory is not present, it will create it, and the command it will use is FastQC and the input files, and it will run it using subprocess.run, very simple Python snippet to do that. And if you want to write it, you can ask ChatGPT to generate this snippet and it will generate it. So it's as simple as that. It's not a very difficult code, but yeah, this function is now converted into a tool. Now with this, agent will be able to run FastQC in my local system. Okay, so once that, I have equipped another tool, that is the unzip the report. So here agent will get the zip file and it will unzip the FastQC zip file, and I've so that's what directory to extract files to, if non extract to the same directory as the zip file, and this is simple zip.extract all package, so using which it will extract it. So my second tool is ready, that means extraction is ready. So now I will write the third, which is the parse basic statistics. Basically here I am loading this file, and I'm just from this block, from basic statistics to end module, whatever the content is there, I'm returning it. Simple Python function. So if it starts with this one and if it ends the end module, then I'm breaking it, and if it starts with this one, then that means I am now into that block, I'm entering it, and then I'm just splitting with tab and key value and I'm returning a dictionary. The dictionary is nothing but your file name, the value, file type, this one, total basis, this one. So I'm returning a dictionary, very simple Python function. Okay, so that's why I written dictionary of the basic statistics. And here I have written that parses the basic statistics section from a FastQC data.txt file, right? So this function is defined now. So now the parse per base sequence quality. So basically what it will do, it will parse this block and it will calculate the mean of mean and median of the mean, and finally it will give me the result like the verdict, pass or fail, which it will get from this one. This parameter it will return me, and it will give me the mean of this column and the median of this column. So basically it will give me the output in this format. So that's how I have written the Python function here. And same instruction I have given, so don't worry of the code. Like if you see, it starts with this one and it ends over here, and then it is splitting into tabs, and then I'm taking this is the starts with this one, right? This is the header, I got it. See, if starts with the hash symbol, then I'm doing the mean, and then I'm doing median, and finally I'm doing the mean of the mean, median of the mean using the statistics package, and finally I'm returning with the this thing. Again, they don't worry about the detailed function. You can ask AI, ChatGPT or Gemini to write this small function for you. You will easy to get it, And then again, the last one is parse all the model verdict. So basically, this will return dictionary that okay, this is the model and it is failed. Next, it will go this module, it's failed. So like that, it will calculate or it will return all these functions. So basically 4 Python functions what we have defined here, 1, 2, these 3, and just decorate it with the function tool. Our tools are ready. Okay. So now let's do one thing. We will be using our local model, so GPT OSS model, because that's where the reasoning is there. So I've defined. So now here is my main FastQC agent. This is what I am now creating. So here I have given a instruction properly. See, you are a specialized agent for FastQC analysis. Given a FastQ file, you should run FastQC on the file in the current directory. Use your unzip tool to extract the generated fastqc.zip file. Then from the extracted folder, parse this file. So this is where I am telling that which file to parse. To what? Fetch the overall basic statistics using the basic statistics parser, then parse this per base sequence quality tool and do this one. And then at the end I am telling the provide a summary including the basic statistics per base sequence quality, pass, fail, mean, median, and all the model verdict. So this is what I am telling it. Okay, and this is my system prompt, the name, the prompt, system prompt, what model I am using, and all the tools I have created. I am just passing it. Very simple. So let's run it. Okay, and let me copy this one, and now the chart session, again very simple, the same thing. So let me pause it for a minute after it starts. Okay, so it's launched. So let's go back. This is my FastQC quality checker, and now I will asking it, this is my this thing. Okay, FastQC quality of my input FastQ file, this one. So let's pass this, and I'm just closing this good bad FastQC. Okay, so this is my logs. Let's check. Okay, so this is my agent workflow. So first what it will do, yeah, it might be a little slow. I will pause for a minute. Once it so give some output, I will resume. Okay, so it went ahead. So this is currently it is progressing. So let's see how it flow, right? So first what it went like, this was the system prompt, okay, and then it was the question I asked, like this is the question, okay. So now the reasoning, right? So now LLM thinks we need to perform steps, run FastQC on this FastQ file. We need to call this tool, then unzip it, then parse this one, and user provided the file this one. The tool expects input file like that. So we run this tool. So you understand that. So now it calls the tool, run FastQC, and it generated, it ran the FastQC, right? So let's see what happens. Okay. So now you see it ran FastQC locally. like it extracted something, all this 100% extraction happened. So after that, now it calls the unzipping one. So it unzipped it, and this file it took, zip file, and it unzipped, and we got the zip file. So that's where we'll see the reasoning. uh, like, okay, reasoning is done. Like, he says that we need to pass this data in the extracted folder, presumably this directory. So call parse basic statistic, these 4 function, then produce summary. Need to use function accordingly. We'll assume the file path is this one. So because I had not specified where the output will be generated, it tries to think. Probably that's what, maybe we will assume the file path is this, it's saying. Okay, so then it correctly it calculated. Now this tool parse it, it parsed this file, and then it called this tool, and we got the output in this format. You see, file name is this one, file type is this one, encoding Sanger 18357 4.1, like that. I think this is the one you see right here. See all this part you see over here. Okay, so now after that, now it is calling the next function, thinking that let's call this function, this one, but it failed here. Okay, so it failed here, here, and it tried to run FastQC data path. It says dot slash, so it called this way, but this is not correct. Okay, and that's what it failed. And then it thought, oh, it's failed, right? Let me retry. So that's the beauty I like about the agentic, right? So in the traditional workflow, if it fails, that means your pipeline fails, right? Now, since you have you're doing the agent, right? Then it again thinks like, we ran this tool incorrectly. We passed this file as dot due to a mistake. We need to provide the correct path. Probably the path is located over here. So now call function again with that. So that's how it thinks, oh, I did a mistake, so let me recorrect it, and let's do that. So now in the second time, it called correctly the function. You see the FastQC data path now passed correctly, this one, and then it got a output like, the result is overall fail, the mean is equal to this one, and median equal to this one. So now it calls to the third one. So now it reasons that, okay, it calls this function parse all the model vertex. Again it failed. It again gave wrongly the path. So that's what maybe we need to modify our system prompt so that it will correctly pass this one. Okay, now it thinks again. It tried to give now this path. Okay, so again it failed, I guess. Error occurred because it give dot something which is wrong. So now it corrected himself again. We attempted many erroneous path. We should give the correct path. Okay, so also need to avoid extra spaces. Provide with the same path. Let's correct. See, now it generated the correct path it gave, and finally it got all the output. So now it got everything finished. So now it gave the final verdict like, okay, says that we have parsed the basic statistics per base, these all thing, need to provide a summary indicate including all this parameter, and need to mention this one, and let's provide nicely formatted one. So that's what finally it gave me an output like this, this output what we got. So let's come back here. So we got what? Wow, nice, right? See, this is what you got, like the basic statistics is equal to this one. Overall it is pass because it's pass over here, right? Which is actually not pass because this is simple statistics, right? But then it called the second tool. Overall it is fail because the mean base quality is equal to 10.35, and here you see, right, it is using his own knowledge as well, a Q score, maybe it has trained with that, right, FastQC, so he knows about the median base quality is what. Then all module verdict. So this pass fail, 1 1 1. Then finally it interprets that the overall read set passes basic statistics, but low mean and median quality indicates many low quality bases. Several models flagged failures like this one, and warnings. Consider trimming or filtering poorly high quality bases or resampling if you plan to use this for downstream analysis. So how beautiful it is. See, like the way we have given the agent to think and asked him to go through this one and provided all the tools. So like as a human, you will go and you will just go. We were doing it like this. Okay, you were looking, okay, GC content is like this, and ATGC composition doesn't look good. Okay, GC content, we see two peaks are there, so maybe it's something wrong. That way, we used to read, and finally we used to decide whether to go for trimming or removing something, those kind of things. So now the agent is able to do it, and maybe we can further add a tool over here in this one. So that means now trim galore, some tool, right, like trimming, and then associate that tool as well. So now the agent will think that, okay, this is the quality is bad, now let me call that, and you can define that workflow is like that. So here, if you look at this design pattern, right, here what we did, we did not define the flow, we gave our agent everything. So now, and we told agent, you do whatever you want. This is like complete autonomy we gave. Okay, but this is little risky, I would say, because you never know like how many times it will try to do this one, and it may fail. Okay, so that's where, if you know that you have to follow 1, 2, 3, you should not design this way. That is what I feel. So because I know that I have to run FastQC, then extract it, then do this one. So what I will do, I can have one agent, I can call this one first, only just run FastQC, then the output, then this one, then I will ask like use this one, then summarize it. So we can have this step by step deterministic workflow, so that we control how the output goes, flows like that. So that way also we can define. So instead of writing the code directly here, right, so directly one liner here, so you can I will just telling you the prototype, like how we can do is here. So let me just show you, like, okay, maybe in next I don't have that use cases ready yet, but you can say, right, first call FastQC, okay. So that means how it will do, you will just runner.run and you will ask the agent to run the FastQC query. Okay, so here for example you can say something like this. Okay, and your message, run FastQC of my input sequence, this one. So you get a result now. So now your second would be now extract, right? Extract the final output. Okay. So so next query would be, okay, now extract the zip, sorry, I'm just not running it, zip file generated by FastQC, then this is a query, and again you call the same agent, but now this time the agent will use that zip tool like that. Okay, so that way you can have one agent specialized with multiple tools. That is also you can do this way. Or the third approach, next approach, what we can do is like, we can have one agent for running FastQC. We have this agent is specialized task is running FastQC. One more agent here which is specialized for extraction. One more agent to do QC, and one is the final summarizer agent. So you can define your workflow accordingly and can do that. Okay. So again, if I just summarize this use case, what you saw, like in traditional way, we used to do any workflow like 1, 2, 3, 4. So deterministic. So we can plan our agent to do that way, and also we can give full autonomy to the agent. So let him do whatever it wants. But you see the beauty, like here you can use the brain of LLM can think like, and based on the QC parameters it can decide like whether it's good or bad. So that's what I liked, the agentic AI kind of development what we see. Okay, so that's all I had in this use case, but yes, you can improve this with more QC parameters, as I said, but this was just to give you some idea like how you can convert your existing knowledge about tools to different new flavor of workflow. Okay, so with that I will stop here, and in the next video maybe we'll talk about something called MCP. It's a model context protocol, and how we will empower our agents to provide more MCP server, so that more capabilities our agent will have. So we'll learn about that. Okay, so I hope this use case was useful, and I really enjoyed it. doing this, and I learned like how agent thinks and doing his mistakes, trying lot many things. So I like this use case. So I hope you also liked it. And yeah, so I'll see you in the next video. Thank you so much.